Okay, this is McGraw-Hill Chapter 6, Section 6. This deals with simplification of radicals and rationalizing radicals. So here's example 1. First problem we have here is we have square root of a to the 6th b to the 4th. Now remember, there's that little imaginary 2 here. So all that little 2 does is divide into the 6 and make it a to the 3rd. Divides into the 4, makes it b to the 2nd. So you get a to the 3rd, b to the 2nd. This one here, you have cube root of 81y to the 5th, x to the 3rd. So the first thing you got to realize is that 81 breaks down into 27 times 3. Cube root of 27 is 3. Cube root of y to the 3rd is y. Cube root of x to the 3rd is x. So we get 3yx cube root of 3y squared. Or this could be written as 3y cube root of y squared over x. Just remember, you got to break these down into perfect cubes. So this 81 breaks down into 27 times 3. Y to the 5th breaks down into y to the 3rd times y to the 2nd. In example 2, just a little question here. If you have square root of a times another square root, and they give you square root of a squared, which gives you a, this has to be square root of a. Because square root of a times square root of a will give us square root of a squared. Here, cube root of y times cube root of question mark gives us cube root of y cubed. So because we have a 3 out here, we got to get a 3 in here, so this has got to be y squared. In example 4, we have 5 over cube root of a. Again, if we have 5 cube root of a, to get rid of this, we got to multiply by cube root of a squared. Because a squared times a, with a 1 here, gives us a to the 3rd. So cube root of a times cube root of a squared gives us cube root of a cubed, which gives us a. But when we multiply the bottom by this cube root of a squared, we've got to multiply the top by the same thing. So it gives us 5 cube root of a squared. Same thing with example 5. Here we have square root of y to the 5th over 7. I'm going to rewrite it as square root of y to the 5th over square root of 7. Remember the little imaginary 2 here. So when that 2 divides in here, it brings us a y squared out. We're going to rationalize by multiplying by square root of 7 top and bottom. This is going to give us square root of 49, which gives us 7. This gives us y squared square root of 7y. Same thing here. This is 15 over cube root of 25s. That's an s, not a 5. So what happens here is the next perfect cube that we can get is 125. So we're going to multiply the 25 by 5 to get 125. We're going to multiply the s to the first power by s squared to get s cubed. That cube root of 125s cubed gives us 5s on the bottom. But when we multiply cube root of 5s squared on the bottom, we've got to multiply it on the top. So that gives us 15 cube root of 5s. This 15 is divided by this 5 and gives us 3. So simplified, this is 3 cube root of 5s over s. The last concept we have here is called rationalizing the denominator by a conjugate. Now remember, a conjugate is nothing more than it's a difference of squares. So if I have 2 plus square root of 6, I'm going to multiply by 2 minus square root of 6. Same first term, opposite signs, same last term. Again, if I multiply the bottom by this, I've got to multiply the top. So negative 2 times 2 gives me negative 4. Negative 2 times a negative square root of 6 gives me plus 2 square root of 6. 2 times 2 gives me 4 minus square root of 6 times square root of 6, which is square root of 36, which is 6. This then gives me negative 4 plus 2 square root of 6 over negative 2. This 2 can divide into here and give me 2. This 2 can divide into here and give me 1. So the answer is 2 minus square root of 6. Remember, your conjugate is nothing more than same first term, opposite signs, same last term, difference of squares. There's another one. This is example 8. Here we have 4 plus square root of x over square root of x minus 7. So again, we're going to rationalize by the conjugate. Same first term, opposite signs, same last term. I'm going to multiply the top and the bottom by this. So when I multiply the top, 4 times square root of x is 4 square root of x. 4 times 7 is 28. Square root of x times square root of x is square root of x squared. Square root of x times 7 is 7 square root of x. Square root of x times square root of x is square root of x squared minus 7 times 7, which is 49. This gives me x minus 49 on the bottom. I can combine like terms. 4 square root of x and 7 square root of x is 11 square root of x. So it becomes x plus 28 plus 11 square root of x over x minus 49. Same thing here. I'm going to rationalize. Square root of 2, square root of 2. Opposite signs, 4 square root of 5. Difference of squares. When we multiply the bottom by, we're going to multiply the top by the same thing. So 3 square root of 2 times square root of 2 is going to be 3 times 1 square root of 2 times square root of 2, which is 3 square root of 4. 3 square root of 2 times 4 square root of 5 becomes 3 times 4, which is 12. 2 times 5, which is 10 inside. 2 square root of 5 times square root of 2 is 2 times 1 on the outside, which is 2. 5 times 2 on the inside, which is square root of 10. 2 square root of 5 times 4 square root of 5 gives me 2 times 4, which is 8. 5 times 5, which is square root of 25. This gives me square root of 2 times square root of 2, which is square root of 4, minus 4 square root of 5 times 4 square root of 5, which is 16 square root of 25. So in terms of this, square root of 4 is 2 times 3, which is 6. Square root of 12 square root of 10 and 2 square root of 10 is 14 square root of 10. Square root of 25 is 5 times 8 is 40. Square root of 4 is 2. Square root of 25 is 5 times 16 is 80. So we can combine like terms here. 6 and 40 is 46 plus 14 square root of 10. 2 minus 80 is negative 78. I can reduce these all by 2. Divide that by 2, I get 23. Divide that by 2, I get 7. Should be 7 square root of 10. That should have been 7 square root of 10. And then negative 78 over negative 39 should have been, negative 78 divided by 2 should have been negative 39. Okay.